My name is Rhiannon Bradley, and today we are going to be discussing light. As we look out into the universe and at the stars, we can see that there are so many things that we can learn. And the way that we learn that is by looking at the light. We can look at it through their spectral lines, but also through looking at wavelengths, or how light travels. I'm going to show this using a slinky. So as we look at light as it travels, it moves in things called waves. And as it moves, we can see what's referred to as the Doppler effect, which is as a source moves away or towards an observer, we look at what the wavelengths are doing. As it moves away from an observer, the wavelengths get a lot longer and a lot lower frequency, and this is called redshift. As it moves towards the observer, they get a lot lower frequency, and they get a lot shorter wavelengths, and this is called blue shift. Now, as we look at the electromagnetic spectrum, we can see this same effect. As it moves to the red side of the spectrum, they get a lot lower wavelengths, lower frequency, lower energy. These are things such as radio waves or microwaves. As it moves to the blue side of the spectrum, they get shorter wavelengths, higher frequency, and higher energy, such as X-rays or gamma rays. Now the question is, once we've looked all this, what can we use it for and what can we learn from it? Now in 1929, Edwin Hubble was looking at a certain set of stars, and these were Cepheid variable stars, and they all have the same luminosity. And so as he was looking at them, he noticed that as he charted them along their velocity and distance, that they made a slope kind of like this, as he charted all the stars on this graph. And this slope is referred to as the Hubble constant. Now, as he looked at all these stars, he noticed that they were actually expanding, that they were all being redshifted. They were being redshifted at this rate, which is pretty much the average of all of these stars, where it was 73 kilometers per second per megaparsec. Now, 1 parsec is about 3.26 light years, and so a megaparsec is a million of those. So for every million 3.26 light years, the universe is expanding at 73 kilometers per second. Now we can use this constant that he discovered by putting it into this equation where velocity equals the Hubble's constant times distance. And velocity is kind of another way of using redshift. And now as we use redshift to measure distance, we can switch this equation around to be distance equals the velocity divided by the Hubble's constant. And by using that, we can figure out how far away objects are from us in the universe. Edwin Hubble also used this as proof that the Big Bang Theory was correct, and that the universe started as one single point and has ever since then been expanding outwards. And this is something that we can still see today as objects are being redshifted from us as we look at light.